Hi students, now we are going to explain an application of Pascal's law by taking an example of a hydraulic lift. Now what is the statement of Pascal's law? In a liquid in equilibrium, okay, by considering the liquid in equilibrium, what is the statement of Pascal's law? Let us read now. If the pressure in a liquid is changed at a particular point, the change in pressure is transmitted to the entire liquid without being diminished. Very simple. You must have seen in the swimming pool. Okay, suppose if 2-3 persons will jump on the surface of water, means the waves produced will be pushing the person at the other end. So this is the best example to understand the Pascal's law. Like that, here I have taken a container, a large container with two openings, one on the left side and the other one on the right side. So the left side opening is having an area of cross section A1, over which a light piston is placed. So the area of cross section of the piston is A1, and the right side there is a large piston of cross section A2 which is floating on the surface of the liquid. Okay, so the left side piston is smaller and the right side piston is larger. So A2 is greater than A1, I have assumed. Now if I will press the piston on the left side with the force F1, I just press the piston on the left side, so that the pressure P1 will be exerted on the piston, and that pressure P1 must be equal to what? F1 divided by A1. Understand that? Similarly, on the right side, this pressure P1 caused on the left side will be transmitted uniformly throughout the liquid, and it will be exerted in the upward direction on the piston of cross section A2. So when we press this piston, this water will be pushing the right side piston in the upward direction. So what is the pressure it is going to exert is P2. What is the force exerted is F2. So P2 must be equal to F2 divided by A2. So on the right hand side, the pressure acting on the piston in the upward direction is P2 is equal to what? F2 divided by A2. Now, as per this statement, the change in pressure is transmitted without being diminished, we have mentioned, isn't it? That means what you understand, P1 must be equal to P2. So this P1 must be equal to P2. I am going to substitute for P1 and P2. So F1 by A1 must be equal to F2 by A2. Okay? So I want to express F2 in terms of F1. Therefore, what is F2 is equal to this A2 by A1 into F1. So this is the required equation as an application of Pascal's law. The upward force F2 acting on the second piston is equal to how many times the downward force exerted on the left side piston we have mentioned. Okay, here this term A2 by A1 is called as mechanical advantage. Mechanical advantage. Why it is called so? Suppose if A2 is 5 times wider than A1, so that A2 by A1 is equal to 5, then F2 will be 5 times that of F1, is it not? Yes, you are applying a very small force, 5 times larger force will act on the other piston, so that if some heavy objects are kept on the second piston, means easily they can be lifted with a small effort, isn't it? So now in hydraulic service stations, automobile service stations and all, they will use a hydraulic system for what? For water washing the bus, lorry and all, for doing the cleaning of the bus, bottom parts of the bus and all, they will keep on a platform and all, they will rise to a greater height with less force. Even if you apply less downward force, a very large upward force will act on the other side, so that even huge objects like the bus and lorry also can be lifted very easily. So this is called mechanical advantage. When will we have more advantage? When A2 is many times greater than that of A1. Understand that? So F2 is equal to A2 by A1 times F1. Now this is also called as force multiplier. This equation also is called as what? Force multiplier. Yes, I told you, if A2 is 5 times that of A1 means that the force is multiplied by 5 times. Suppose you want 10 times force, then the applied force means then area A2 must be 10 times A1. So it is called as what? This mechanical advantage. A2 by A1 is called as mechanical advantage. So where it is applied, I told you, in the automobile service stations to lift very heavy vehicles such as the bus and the lorries, trucks and all. Another application is, you must have seen the brake system in the heavy vehicles like the bus. How does the bus driver apply the brake? In cars and buses and all, there will be a brake at the foot. There will be a pedal. Slight press of the pedal also will stop the huge bus very quickly. Why or how? It is also an application of what? Pascal's law only. Hydraulic brake. It is called as hydraulic brake. There is a tube connecting the brake pedal with the discs, inner discs of the wheel. So that when you apply a slight force on the brake pedal, a pressure P1 is caused, and that is expressed by this equation. P1 is equal to P2 or F2 is equal to A2 by A1 times F1. The brake pedal area will is A1 and the area of the disc inside the wheel is A2. So that we have a mechanical advantage, and a large force will act on the inner surface of the rotating wheels so that it will be easily stopped. So my dear students, the application of Pascal's law, one is hydraulic lift, the other one is hydraulic brake. I hope you must have understood this well. Fine.